Hello and good morning, good afternoon, and good evening to the webinars today, Unlocking the Power of Zero Energy with BIPV Solar Materials. This is brought to you by the Architectural Solar Association and the Net Zero Coalition. The webinar will last about 1 hour, and you will be able to ask questions throughout the event using the Q&A section on the bottom of your screen. You can post questions up and individuals will be able to respond to you during the course of the webinar and at the end of the webinar where appropriate. Please about 1 week after the webinar, we will send you a webinar recording link that you can download or forward to friends and associates that might also be interested in this. Today we have about over 200 viewers, potential viewers. Many of them are just signing on now, and you'll be speaking from around the world, from viewers from around the world, and we have speakers literally from around the world, starting in California, early hours of California, to Colorado, the East Coast, UK, Spain, and Dubai. So we have quite a good audience that represents what's really happening in the world with BIPV right now and net zero buildings. Well, before we get started, I'd like to ask, we have several questions we will post, polling questions we'll post throughout the webinar as we transition between speakers. And I'd like to post one of those questions now while we get set up for the first speaker. But also I'd like to just make a statement here that enabling mass realization of nearly zero energy buildings by BIPV requires the establishment of a structural collaborative innovation efforts between the PV sector and key sectors of the building industry. Today, we hope the speakers will be able to tell you a little bit about what's happening in the industry around the globe, what are some of the unique situations in each of these markets, and help to enable this market to develop further. But first, we'd like to ask a question. How long have you been involved with BIPV? Are you new to BIPV? 1 to 2 years, 3 to 5 years, 6+ years? Again, how long have you been involved with BIPV? Please answer either new to BIPV, 1 to 2 years, 3 to 5 years, 6+ years. Just click on one of those and submit, and we'll have a kind of good indication of where our audience stands on all this. Oh, interesting. Well, this is very positive. We have over 50% of our viewers today have been involved. 57% have been involved in BIPV. For at least 6 years plus, followed by 21%. The next largest percent are new to BIPV, which is healthy. We get some new adopters in here. And 1 to 2 years is 14%, and 3 to 5 years, 7%. So that's a quite interesting spread. I'm glad we have some new adoptees, and some people have been looking at it for some time. So moving on, first I'd like to start talking a little bit about ASA and what we've been doing over the past a couple of years. You know, we've had it's about 2 years old now. We've acted in a very quiet mode, but we've hosted a webinar earlier this year, and this is our second webinar in the series, and we've got a really interesting group of people. And I thought that the topic was quite interesting with this kind of convergence of the net zero and BIPV. At some point in time, I think we're moving towards an environment, which we're not there yet today, but sort of a cost neutral over time, where integration of BIPV will be cost neutral into the building envelope, building construction. So it doesn't become this obstacle that many see right now. I think some of it is perceived problems. Hope we can discuss that. But right now we have this mandated operation that's developing around the world. And we also have a bottom-up application. We'll have speakers from both. And we have Europe has mandated these, and some of the cities in the United States have mandated the adoption of net zero construction. And others in corporations, it's a goal. So with that being said, we'll move on to giving a little introduction to who's going to be speaking today. It's myself, Browning Rockwell. I'm the executive director of ASA, and Chris Klinga, who's the technical director of ASA. We've been working together for about 1.5 years now to launch this and build it. We also have Ann Cooley from Pilkington NSG. She'll be talking about expanding the vision that that Pilkington NSG sees. And I think one of the things she has in her slide that struck me is it said, think differently. And I think that's very true about this topic. We have to think differently about it than we have been to date. And I think Pilkington and NSG are establishing some leadership in there, and Ann will give us some background on that. Chris is going to give a quick overview of some of the technical issues and commercial issues on BIPV. Next up after Anne, we'll have Laurent Quitre and Paul Courtevel. Laurent is one of the kind of pioneers in BIPV. He's been at it for many years, been working out of his base in Belgium. Quite familiar, has some very interesting projects he can tell us about. And he's going to talk about why buildings that generate electricity cost less. So I think that's an interesting concept he'll be presenting, but he's got many projects that are very, very, very timely for us to be talking about. And finally, we'll have Anne Edminster from the Net Zero Energy Coalition, and she's a green buildings consultant. Anne's going to talk to us a little bit about zero energy plus architectural is a perfect match, which makes a lot of sense. And she's going to talk a little about this from the residential side through the multifamily housing and commercial. And finally, we're going to have a moment where Anoop Babu from Dubai will give us a brief overview of what's happening in Dubai and what's coming up with one of our media sponsors on the Big Five Solar DMG events, an event that's taking place here in the next week or so. First off, just give you a little background. The ASA's mission is an industry advocate for standards development, education, legislative regulations, building and energy codes, and solar architecture design specifications as they relate to integrating solar into the architectural envelope. We represent a growing industry with a common goal of transforming building facades and other architectural surfaces into generating assets. Again, this is, we feel very strongly that the concept of BIPV, it means a lot of things to a lot of different people. Architectural solar is the more appropriate way to discuss this because it's a broad area. And some of our key goals and objectives right now are standards development. Within the USA, there's a UL 1703 is a major barrier to integrating solar architecturally. We're now, we've just recently joined IEC committees. We have representatives from Europe, the US, and the Middle East now on that committee that's looking at BIPV standards from a global perspective, which will be very helpful in moving this forward and having a dialogue of kind of the best of breed, best of specifications that we can work with. So we're going to be collaborating with the more mature markets as ASA, but also with these different events and committees we'll be participating in. Demand creation. ASA's market research looks to bring awareness to various financing mechanisms that could benefit the architectural solar market. This is a key element, is understanding the business of architectural solar and BIPV, and Chris will speak a little bit about that. And building industry adoption. We feel that this is architectural solar has been around for 30 years, but it's entering a new phase in its evolution now with the advent of the net zero energy, net zero buildings. Is bringing to the forefront a lot of discussion about this and breaking down a lot of the barriers for adoption and growth in the market. So Chris, if you could take on from there and we'll talk a little bit about what you're up to.
Well, thank you, Browning. Thanks for the great intro. First and foremost, I'd like to get off on a good start understanding the multifunctional benefits of BIPV. The benefits and differentiators of architectural solar or BIPV lie in its multifunctional nature, and it's what has generated all the buzz over the past several decades, and will also be how proponents of architectural solar will justify it to the traditional building industry decision makers. So here are a list of applications for BIPV or architectural solar, and starting at the top, you've got canopies. And we go all the way down to vertical vision glass, and they're ordered in a way that really just shows you how integrated they are and how difficult they are to implement. Canopies being easiest to implement, they're not enclosing the building envelope, but they are an architectural statement. They provide weather barrier and shading. Then you can go down to just simple architectural structures, which give branding and messaging opportunities for a business, which is really hard to quantify from a financial standpoint, but all architectural solar does have this intrinsic value of messaging that we really need to learn how to quantify and value. Next down, we've got window awnings, rain screens, balustrades. As you can see, as you get more integrated, the multifunctional advantage goes up, but it also gets harder to implement. So when the value goes up and it gets harder, that means that we need to break down the value, the barriers in front of the harder to integrate options to really open up this market. And so really where as much as I don't want to talk about cost today, unfortunately, at the current state of the market, we need to keep talking about cost because BIPV is not commonplace like a IGU is or a low E coating. People have to make the decision and it continually gets value engineered out. So we need to be educated on how to estimate the cost and what the return on investment is based on. And that is the incremental cost of BIPV. And if you look at laminate that's utilized or safety glazing that's utilized throughout the architectural industry, you have a monolithic light, an encapsulant, and a monolithic light. In a PV laminate, the added cost is only the PV cells and interconnects, the added layer of encapsulant and the junction box. So you're essentially getting that glass light, the first glass light, the first layer of encapsulant, and the back glass light for free because that's already been included in a traditional building material. And then you step into the PV-IGU space, and it's the same equation, but now there's actually PV makes up a smaller component of that architectural material. And so now that we've got the incremental cost of the module taken care of, we need to understand what the fixed cost is on the installation side. How does a BIPV installation compare to a traditional PV installation? And what I've done is I've looked at the NREL studies over the past couple of years, and there's recently a new one out that we have yet to analyze, but we're excited to because it shows a further cost reduction in the hard and soft costs of PV. And this analysis right here is what it does is it reduces, we look at what it costs to install a commercial PV system that's above 100 kilowatts, and it's around $229 a watt. Then we say, well, the structural component, we take that out completely, and the module component, we take that out completely. And there you can see the module is assumed at 64 cents a watt, and all of this is in US dollars, by the way. And with the margin and everything that gets lumped into it, that's a 80-cent reduction. And you can see everything there, how it comes down to $1.12 to $1.28, depending on what your install labor and equipment reduction is. And that's a really interesting number, and it's something that everybody should take home from this presentation to understand that that is the fixed component, that's the baseline installation cost. So when we take the incremental BIPV module cost, which can range anywhere from 62 cents a watt up to 350 a watt, depending on the architectural constraints of the project, we add in the baseline installation costs, and then we take off any quantifiable multifunctional value. And this could be, a frit that the PV is replacing. There's a lot of different things. Maybe the PV is serving as a sound barrier because it's a laminate, and a better sound barrier is needed on the outboard light, so you can take more value that way. Those things need to be quantified, and then we end with a total incremental cost. And this is how BIPV needs to be analyzed from a ROI perspective. And so from here, I'll let Anne take the stage, and
as we transition to Anna, excuse me, I keep calling her Anna. Anna Coley from Pilkington NSG. We have another polling question we want to present to everybody, and everyone as we process and go through this. If you could put up this question real quick. Question is, would you consider becoming a member of ASA? Yes or no? It's very straightforward. We're just trying to gauge a level of interest, and certainly you should maybe visit the site and see more about what we're doing, but just curious on your interest level. If you can answer that question, would you consider becoming a member of ASA? Yes or no? I'll give you, say, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And if we could post the results there. Well, good. That's a positive note starting out here. We'll see if that pertains to the rest of it. 82% indicate they're interested, 18% no. So that's fine. Well, we have to work on that 18%. So Anna, if you could take it from here and tell us a little bit about what NSG Pilkington are doing and what you're doing with your research and R&D efforts and other outreach, we'd be most interested to hear that. Thank you.
Okay, thank you, Browning. And greetings everyone from the UK. So I'm going to talk to you a little bit about why Pilkington NSG as a glass company is focusing on architectural solar. and why we feel that photovoltaics will help Pilkington expand our vision with glass. So imagine a world with no glass. It's going to be a pretty dark place or pretty drafty. So glass is an amazing material. It's really versatile. It's very beautiful, but it's at its heart has always been its property to allow us a connection with the outside world. And that is what we want to maintain. But glass has changed considerably over the last many years, since the 1950s when the float glass process was developed. And most of those changes were done in order to improve our lifestyle, to give us more comfort in our buildings, or to add an extra function. But as the glass keeps evolving, we need to ensure that we're meeting our society's changing demands. And it's the reactive or responsive element of the glass that we think is going to be key moving forward. So buildings are affected by their environment all the time. They're heated, they're cooled, they are affected by whether it's night or it's day. So glass has always been seen as something that's quite passive. So it's actually, is actually affected by its environment, but doesn't necessarily respond to it. And we see a change as needed, and that glass panels and facades need to actually work with the environment and actually respond to them to become a much more dynamic part of the building. So what do we mean when we're talking about this dynamic facade? Well, there's a few different categories that fall into this. So switchable glazing is something that's very interesting, and that it adds privacy. It can also provide shading. So it's definitely something that's a dynamic area of glass. Heat generation, so this is another area that could be to provide comfort or demisting. So some of the issues you see with condensation, actually be able to heat the glass has lots of potential properties. Lighting, so we're seeing a change in how lighting is seen as we're moving towards more low cost, more energy efficient lighting. Glass has a role within that, and that can be aesthetics or function. Display, so you're seeing a lot more of displays actually been integrated into buildings, particularly things like shop facades, and that can be for entertainment or advertising purposes. And obviously the last one, and the one that we think is really important, is energy generation. And obviously with changing legislation and the fact that by 2020 in Europe all new commercial buildings need to be nearly energy zero, it's something that we need to start focusing on now, and we need to have some good solutions to the issue, and looking at ways of improving how we can capture the sun's energy. So using photovoltaics on buildings is nothing new. It's been done for many years now. Obviously, if you look back, and the more traditional sort of PVs of just attaching them to the outside of existing buildings, that's been something that's been done for a long time. But, obviously has a lot of issues with certain buildings, and that you need to actually be able to see out of them, and that solution wouldn't necessarily work. So the more kind of recent developments you're seeing where the PV element is actually laminated within the glass, and that can give a nice stylized look. And there's a few solutions that are starting to be seen, particularly in a lot of our cities now. But again, there's potential issues with a lot of those, particularly when you've got these sort of large blocks of PV that is blocking your view. So what we think going forward is this concept of style without compromise. So a lot of these buildings that architects design are very beautiful, and that they don't want to change that, and that shouldn't be changed. The people that live in the buildings or work in the buildings should still have that view out that they would always expect, and also the aesthetics of the building from the outside shouldn't be compromised just because it's becoming an energy generating building. But if you look, obviously the roof space is very limited, and that is never going to generate enough energy to make a building almost net zero. Whereas if you look at the facade, so the glass areas, there's a lot more opportunity there for integrating PVs. So the solution that we're looking at and have developed along with Solaria is using an amorphous crystalline, sorry, not amorphous, a monocrystalline silica cell that is then sliced into small strips. So that gives the benefit that it's a well-established technology with lots of testing, good stability, but you're still able to see out of it. It is not restricting that view. There's a 50%, at least 50% transmission through it, and that view is not being restricted by large pieces of PV. And also it has the benefit that it can be combined with a number of different coatings. So you're still having the same properties that you'd expect from a normal, glazing in a building. So you're still having that level of comfort that you would expect from a normal glass plane. So obviously we've done some testing with this technology. We have a partnership with the University of Swansea, and they have a energy positive classroom that they have developed, and they've installed one of our PV windows, and that has the benefit that they are able to track how its performance is day to day, and looking how it compares through the year. So we can get a lot of useful data out of that. And obviously every project is going to be individual, and as a company, if a customer is interested in installing our PV solution, it's the SunPlus BIPV, we've got to consider obviously the location, the orientation, the building design, how much vision area there is, and also any shading. So every project is going to be unique, and it's really important that we support every project on an individual basis, and that's of course is predicting how much energy that solution will actually give to the end user. So this is just a simple modelling that we would initially do to give the customer an idea of how much energy that their system would actually generate. And this is just based on a building in London with a south-facing facade, and you can see the dimensions. And it's also including looking at the spandrel panels. So obviously these are not the vision areas, but if you integrate the spandrel panels as well, which are non-vision, you're obviously enhancing how much energy you're generating quite considerably. So we can look at combining both of those to give a total annual yield of in kilowatt hours per year. So moving on to my last slide. So going forward, obviously the aim is that more and more of these buildings will start to integrate architectural PV to become energy generating stations. But going forward, we're going to have to think a little bit differently about how we actually use and harvest this energy. Is feeding it into the grid the best use of this power? When we design the buildings of the future, should we consider how we would actually store this energy so it can be used much more locally? And this seems a more sensible approach, particularly when you have so many things within the building which would actually be able to use this power. In some of these areas that we've considered, you can look at obviously glass radiators, heated wall panels, and also heated windows for comfort. So there's lots and lots of ways in which this energy can be used within the building. Okay, so I think that's the end of my presentation, but obviously if anybody's got any questions, then feel free to type them on the question and answer little tab at the bottom.
Well, Anna, thank you very much. I like that think differently style without compromise is what I have come away with in this, and I think it's what we're seeing is improved design tools and technology improvements and new financial instruments that will properly value and finance the development of architectural solar and net zero buildings. We're going to see the advent of an explosion of this type of development. So I think with people like NSG and Ann doing research leading way, we're in good shape here. But please, if you have specific questions you'd like to ask one of the panelists, please post them and we ask them directly or at the end of the event. So if you could, we have one, as we move into Laurent's presentation, we have another polling question I'd like to put up briefly. Again, it's really helping us to shape the discussion and learn a little bit more about the audience. But the question, our third question is, rank the importance of addressing the following barriers to architectural solar, from most important being 1 to least important being number 7. And that would be building industry integration, codes and standards, project economics, lack of financing solutions, lack of product solutions, and education integration methodology. Again, with this ranking process, rank the importance of addressing the following barriers to architectural solar, from most important being 1, least important being 7. And you can select them. So I'll give you a countdown: 10, 9, 8, 7, 6, 5, 4.
Hey, Browning, maybe since you can just select the answer,
Yep.
I would just ask everybody to just select what's most important
That's
to them.
fine. Okay, we'll select. Everybody can select that, and then we'll go from there. Okay, ready? Building industry integration, very, very good. Building industry integration, 55% of the responses indicate that building industry integration is the most important issue, which is something we're talking about today. Codes and standards, which sort of falls into place. Project economics, lack of financing solutions, lack of product solutions, and education of integration methodology. So obviously one of the biggest barriers is building industry integration. So that's something that we are certainly working on and need your input and participation to work on that. So with that, I'd like to pass it over to Laurent to give us his presentation. Laurent's going to talk to us about why buildings that generate electricity cost less, and talk about active building materials. So Laurent, if you could take over and let you talk now.
I'm afraid I have some. Can you hear me?
Fine.
Can you hear me, Browning? Oh, okay, I didn't hear you very well. Okay, thank you. Yes, I'm going to present the vision of ESOL about BIPV. Is it okay, Browning? You can hear me? Okay. Yes, just a quick introduction about ESOL. So ESOL, we've been active for almost 12 years now. We are quite pioneers. We are manufacturers of PV glazing in Belgium. And of course, besides that, we have quite a big engineering office to manage the projects and work with architects and other engineering office. As everybody knows that PV electricity has come down a lot now. So it's very affordable in most countries. And this is very interesting because this gives a new challenge, a new possibility for buildings in general. So really we can start doing new kind of projects, and this is a driving force, a new driving force for the building industry. Now it's very interesting if you compare the price of a PV facade 10, 12 years ago when we started, and the price of a PV facade nowadays, you see that the price have been reduced quite significantly. We had a price of a facade approximately price of 900 euros to $900 to $1,400 per square meter. And today, probably now we can make projects with $300 to $600 per square meter. That's a big difference. And the difference is also coming thanks to this technology that's been reducing drastically the price. So in 2006, 72% of the PV technology was part of the cost price of a facade. Now it's only 25%. So it's very interesting to compare that because the technology has done the job. The technology is cheap now. What has to be done now is the industry, the construction industry has to take the challenge to improve that. It's always very important to avoid comparing BIPV with PV. PV is made to produce electricity only. When BIPV is made firstly to produce, to be a building material. So it has this double function. The first function is to be a good building material. The second function, of course, is the electricity. But we don't want to put the electricity before because it has to be a very good product, building product, rather before being just a simple device to produce electricity. What is very important also for people joining us from other industries, sometimes people are getting afraid about BIPV, what is this? Actually, for architects, engineers, they should consider that BIPV is actually dealing with laminated safety glass, okay? So the closest product that you have to compare is not exactly a solar module, but you should compare BIPV like traditional laminated safety glass with the only difference that solar cells are placed inside of the PV glazing. Now, it's a glaze. It gives you a lot of possibilities, like shape, size, thickness, whatever. So we have a lot of possibility coming not from the PV industry itself, but from the glass industry, which is giving us a lot of different possibilities in terms of coloring, rendering, and shapes, etc. Okay, so consider a BIPV not as a PV solar module, but as a PV laminated glass, with all the creativity that can be made out of that. Also, all the technology improvement and new innovation coming from the glass industry itself. If you look a little bit at the roadmap of ISOL, we started as pioneers in 2006. We started with a lot of exemplary masterpieces in Europe, in France mostly. Now we see that the market is also very interesting for office building, industrial building, eventually also for residential building. This is going to happen probably. But if we want to take the opportunity to go on all those segments, we have to unlock something, which is how to finance that, okay? Because most of the investors, most of the promoters, they are afraid of this technique, BIPV, because of the price mostly. So we have to give them a solution for that. And this is what we are trying to do. And if we want to unlock this potential, probably the best way to do it is to help promoters to finance those projects. Now, this is a few examples of masterpieces that we have been doing in the last years. A lot of projects in Paris, in Norway, Sweden, Switzerland also is a very good market. There's a nice project in Paris. This is the courthouse of Paris with Renzo Piano, where we have Brise Soleil here. This is a project from Shegi Ruban in Paris also, Cité Musicale. Then we have an office building in Oslo, which is absolutely green and productive, because those glasses are producing electricity. This is a project that we have done also in Rouen, in France, which has been done with a laminated safety glass that are including some kind of an interlayer inside to give this dichroic color. This is, of course, also producing electricity because the laminated safety glass is equipped with solar cells inside. This is more traditional roof in Switzerland that has been done with a printed glass, Latura terracotta printed glass, a special technology inside to avoid the loss from the printing, the coating that we print on the glass. This is a very old project for us. It's 2010, and this is one of the first projects that we have financed ourselves. This project was done during the real estate crisis in Europe, and especially in Spain. And this project was condemned because the Metrovissa company didn't have the access to make this project. So we found a solution to finance it, and it became a reality in 2010 already. IGU, you know that isolated glass is very interesting also to integrate solar cells inside. And we can really say that today PV and BIPV is a new construction standard. It's not just a utility, it's firstly a new construction standard, and all buildings that will be equipped with that in the future will have probably more value on the real estate market than if they were not equipped with this kind of standard. Now, if we come to the cost, it's very interesting because everybody is asking what is the cost of BIPV? it's impossible to define the cost of BIPV. The cost of the BIPV is actually the underlying construction material, you know. So if you have an underlying material like double glazing or simple glass, the cost of BIPV product, the end BIPV product, is different. So today we consider as a variable that the cost to make a glass active, okay, or facade active, is about $250 per square meter. Okay, this is the cost. Okay, so every facade, every every canopy that you would like to make active, okay, you can consider an average cost to make it photovoltaic of about $250 per square meter. Okay, that's a general rule that we take. Now, this glass, okay, this activated glass, okay, is going to generate revenues. Okay, we can consider a south facade, a south-oriented facade, okay, equipped with solar cells inside of the glass. We can consider that the revenue made from auto consumption is about $40 per square meter and per year. So this gives us a very interesting business model to develop, because actually we can finance this extra revenue which is coming out of this facade. So if we consider a non-active facade, curtain wall facade of about 300 square meter, $300 per square meter, and we compare it with a traditional, we compare it with an active facade, where the cost would be additionally increased by $250. At the end of 20 years, we noticed that the non-active facade is still $300 per square meter, when the active facade has been generating in 20 years a surplus of money. And this surplus is very interesting, because we can finance it with third parties investment or other kind of financial model to develop. And today, the priority for a company like us is to unlock this potential and to propose the solutions to the end customers, where we can actually propose to reduce the cost of the investment by taking into consideration ourselves the cost of the activation. This is it. Thank you. Okay,
Laurent, thank you very much for that very, very interesting presentation. I hope my audio is still not bad. It sounds like it's crackling a little bit. So we have another polling question we'd like to ask. We can pick that up right now. We can go through that, and then we can But I do want to make just a quick note comment about Laurent's presentation about cost of active facades. And the fact that we're really looking at a new construction material here, and I think he's referenced that in his presentation, which is quite apparent and worth further discussion and investigation.
Browning, can I just ask everyone to mute their line if they're not speaking?
Okay. So we have a final question here. What can ASA do to help your organization? This will be very important for all of us. After all this discussion, you're learning a lot of new issues today, but host educational webinars, including project and product-focused events, participate in trade shows and conferences where you could share space and perhaps exhibit and let the world know about your products and services, provide project opportunities, matchmaking services, promote your company products and or services on the ASA website, assist with industry standards development and compliance, and publish industry white papers and business intelligence. So if you could go through those questions, just check one of those, and we'll have a countdown, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And we'll see what the audience thinks here. Again, great. At least we're passing the test here. Hosting educational webinars, including project and product focused events. As I said in the beginning of this, this webinar is being recorded and will be posted on our websites, and you will also get an email with a link to that, also to all the slides that you can share with others and extend the discussion. Followed by that, we see that people want to assist with industry standards, which was highlighted previously. Publish industry white papers and business intelligence. This is something that's very key and essential to what we want to do with ASA, but we welcome your contribution to that as well as people working in the industry. And then we have provide project opportunities, which is something we hope to do through these events and our website to create matchmaking operations where we can post up opportunities where people are seeking the products. So we'll have project profiles and company profiles on the website that you can go in and go through a catalog of all the different companies and what they do. And then I guess participate in trade shows and conferences where you can share space. I'm sure there are a few of you out there that would enjoy that and promote your products on the ASA website. So, well, thank you for your responses. We're going to move on now to Ann Edminster, who's sitting out patiently in the Bay Area of California today and got up early to join us on this. But I like her introduction here, the perfect match, zero energy plus architectural solar. I think this speaks a lot to what Laurent was talking about in his presentation about, we're creating a new construction standard, new construction element. So Ann, if you could take it from here and tell us a little bit about your thoughts on this. Thank you.
Absolutely. Hello, everyone, and welcome. As Browning said, I really do see zero energy and architectural solar as being the match made in heaven, if you will. In reality, zero energy is nothing but an efficient building with solar. So we're on a transition to more and more solar, and I'll walk you a little bit through that story. But first, just the background. I've done many, many presentations on zero energy and occasionally have made the mistake of assuming that my audience already knew exactly what zero energy was. So we're just going to start with the basics. We're not talking about an off-grid project. We're talking about a building, a campus, a district or community that is powered by renewable energy while being tied to the grid. So there is a continual interplay between the grid and the building or buildings involved. And the idea is that we're looking to balance the renewable energy production with the renewable energy demand of that system on an annual basis. Now, there's a lot more that goes into it. We're more and more understanding the role of storage as well and other components, but this is sort of the very basic. And this is something that is happening worldwide. We're seeing a very, very rapid transition from individual projects, smaller buildings one at a time, to larger and larger projects. And I've found zero energy projects on virtually every continent. So it's been a tremendous growth trend. And here's one representation of that growth trend from the New Buildings Institute. They have been tracking the development in commercial buildings in the US for a decade plus, and projections backwards to the beginning of the 21st century. And we can see what starts to look like the classic hockey stick growth curve. And I think everyone on this webinar certainly hopes and anticipates that that is exactly what this is. Lux Research in some studies that they did a couple of years ago were anticipating a tremendous growth in this field, as you can see, soaring to more than 1.3 trillion market by 2025. And perhaps this is even an underestimate given what we are seeing. In terms of the commercial buildings per se within the US, again, this is something New Buildings Institute is tracking, looking at on a biannual basis. And you can see that there's a breakdown. We lump a bunch of different performance levels into the conversation when we discuss zero energy, because we're not so much interested in whether or not a project exactly hits the zero energy mark. We're interested in all the buildings and projects that are in the realm of zero energy. So we're including highly, highly efficient buildings, as well as what are referred to emerging buildings, where they're designed to achieve zero energy, but perhaps we don't yet have the full performance data on those projects, or they are designed to accommodate renewable energy systems that may not yet be installed. So we look at the whole universe of projects that are in that target zone. On the residential side, the Net Zero Energy Coalition, of which I'm a board member and project director, has begun also tracking residential growth in the US and Canada. We did our first baseline study in 2015, or rather gathering 2015 data, published that study in 2016, and then subsequently published our second study of the 2016 data, published in 2017. And so we have our first, for the first time this year, we were able to look at the single year-over-year growth in the residential arena. And again, it depends on what you count, but I think the residential units are probably the most significant indicator here. And we saw a 33% growth in the number of units in a single year. So we have a lot more data to track, and we're beginning on our 2017 inventory this month, and we'll be publishing in the spring the numbers for 2017. So it's going to be really interesting and fun to see what growth we have for the next year. One of the real lessons from our inventorying efforts has been to give some thought and analysis towards what is driving the growth. And what we've observed is that there's a very interesting feedback loop going on where grassroots efforts are inspiring policy efforts, and those policy efforts in turn inspire or induce more grassroots projects. So it's not necessarily one or the other, that policy drives growth or that individual developers, architects, and builders or local jurisdictions are driving growth. They're all sort of pushing along this cycle. And so there are all kinds of points of intervention, and we really encourage getting involved in this, whether you are a public agency official, a staffer, or anyone within the building industry. There's an opportunity for pretty much anybody who operates within this ecosystem to get involved, put their shoulder to the wheel, and drive growth in this area. So one of the more revealing things, again, we looked at the geographic distribution of our inventoried projects, and you can see very distinct clusters here, the two most notable ones being California. And being a Californian, of course, I always like to brag on California. We know we're different and special. And, you know, we have a very friendly rivalry with our colleagues on the East Coast, the Northeast in particular, which have also been real pioneers in advanced energy practices for quite a long time. And so what we see, Massachusetts being a very small state, but number 2 in the number of zero energy housing units in our inventory, next to California's number 1, a much larger state, admittedly. And we see that these are the top states also in terms of policy initiatives, both at state levels and at local levels. So very important to really observe this effect. Another exciting thing that our inventory has revealed, the numbers I showed you previously only represent the first 3 categories on this slide, the projects that are completed, those that are under construction, and those that are in design, which we deem to be real in the sense that resources, funding have been allocated for those projects. On the other hand, there is a huge number of units in the pipeline if we also include those that are reported as planned units. Now, planned projects, as we all know, sometimes come to fruition, sometimes do not. So we don't treat these numbers with the same level of credence. Nevertheless, the indication that there's about almost 4 times as many units in the pipeline as we have counted to date is a very exciting indicator. And while we certainly don't expect them all to materialize in the 2017 inventory, we're looking forward to seeing what is revealed by that. Another important trend, particularly in light of our webinar topic today, is the trend towards larger buildings, even in the residential arena. So in our baseline inventory, 50% of the units, were multifamily units in 2015. That number is up closer to 60% in 2016. And most of our multifamily projects, even in the US and Canada, are multi-story, and we are an urbanizing culture. There's more and more focus on transit-oriented development, and that always means verticality. So we are an increasingly vertical development-oriented culture here, catching up perhaps someday with our European counterparts. Now, this graph, it could potentially boggle the mind, so don't get too bogged down in it. But what this represents in broad strokes is a feasibility study that was done 5 years ago by Arup for our local utility in Northern California, Pacific Gas and Electric. And this was to look at the relative feasibility of achieving zero energy in projects based on the project type, the building type, which is shown along the bottom axis, and the climate zone, which is shown along the z-axis over on the lower left corner of the slide. We have many climates in California, from pretty cold. We have climates that are similar to Chicago, and then of course we've got crazy hot in our southwestern or southeastern corner, very similar to the deserts in Phoenix. And so the darker, the red and orange colored representations in the right-hand side of the slide are the climate zones and building types where we really have a harder and harder time achieving zero energy with the current rooftop solar technologies. And so these are the areas where we really see the huge potential to meet the zero energy needs with architectural solar. Because here in California, we do have a goal of achieving zero net energy with all residential development by 2020. That goal is shifting a little bit. We may push it out a few years, but then also with all commercial new development by 2030. So we're going to need that architectural solar on all our applications before too long. I wanted to just add a couple of things at the end here. Browning and I spoke a couple of days ago about the notion of cost, and I wanted to share my view on this, which is something I'm quite fond of talking about, because I think it's really important to emphasize that when we are talking about a building that has a renewable energy capacity to it, a building, again, project, district, and so forth, it's really not the same product as its counterpart or non-counterpart, arguably, that does not include energy production capability. So we're providing a product with a value add, and that value add means they can't really be compared. So we're providing a lot more stability in terms of future utility costs. We're providing more potential for autonomy for that project and other functions, which are, I think, quite exciting that we've seen in the other presentations so far. So I think we need to get a little more creative in how we talk about these projects and the values that they represent to all our audiences, so that we are not shortchanging the product that we're presenting. The other thing that I think is really important is when achieving zero energy is part of the goal of a project, we actually can't conceive of it as an added cost, because one of my favorite analogies is if you were remodeling your kitchen, you can't, whether including the stove would cost extra or not. A stove is part of a kitchen. If that's part of your goal, then you don't think about it as, well, do I have enough money for that or not? Implicitly included it within your budget and your project goals, and you work with your budget in such a way that you achieve those goals within budget. So we have to stop asking the question, how much extra does it cost? That's actually not a relevant question. It's not a helpful question. The more important question is, how do we achieve all of our project goals within our budget? That drives a very, very different thought process and a very different design process. And that is the thought I want to leave you with. Thank you very much.
Well, Anne, thank you very much. Again, I think this idea of architectural solar bridges the gap between energy efficiency and net zero buildings is a theme that we can kind of follow throughout this webinar. I do want to make a basic, just an announcement that Paul Carteval from WIG was unable to join us live due to a family emergency, but he had some slides which we will make available for people to view. And we look forward to having Paul join us on another event. But I think the themes that we've seen today are quite interesting. Everything from the idea of a BIPV architectural solar as a new construction standard to idea of style without compromise. I think we are seeing a whole new era of architectural solar and BIPV, an industry that's been around for 30 plus years, but is just now coming into its own. And I think you've sort of seen that today through a number of the speakers. So with that said, I'll pass it over to Anoop in Dubai, who can tell us a little bit briefly about what he's been doing there and some of the interesting things that are happening on the horizon in the Middle East and beyond.
Thanks, Browning. Hello, everyone. This is Anoop, and I represent the MENA region for ASA. In fact, I should thank again Browning because I was a participant for the first ASA webinar, which happened in February, and that's how myself and Brownie started talking about ASA. And I got involved into this because of a couple of projects which I handle in here is also having some part of BIPV, which is very much going ahead in a very good pace. So I just wanted to start this with one of the recent updates which was announced last month regarding the new climate change plan. So in that, almost half of the UAE's power needs will be coming from renewable energy sources by 2050. And of that, it is going to be 44% of renewable energy. And the main objective of the plan was segregated into three categories. That is, the managing greenhouse emissions while sustaining economic growth. Then we have building climate resilience through stronger climate adaptation and advancing the UAE's economic diversification into innovative sectors. So we kept this in mind, and we approached all the regulatory bodies in here. We represented ourselves, and there are a lot of new projects which are coming up in this region. And as you all know, by 2020, the World Expo is happening here, and in that as well, we have a lot of innovative PV integration which is happening. So, and one more, a major step which was taken by the government is now the Dubai Electricity and Water Authority. They are coming up with the net zero energy building, and it is going to be the world's largest and the smartest building, government building. So we are also involved into some kind of test protocol definition for this particular geographical region because of lots of and we have a lot of mitigation process going through with many authorities and and the most interesting part of this region nowadays, the architects are proactively involved into having this PV integrated into their architectural design. So the most challenge all the guys will be facing is finding out the right product and the right certification and the right standards and right codes which we are trying to develop globally. So to summarize, ASA is now I have already partnered with Dubai Solar Show, which is the solar event exclusively done by Dubai Electricity Water Authority, which happened last month. And 23rd to 21st, and we were part of it, and we got very good feedback. And now we have a big five wherein I'll be talking about the topic where solar and construction meet, that is integrating PV and energy efficiency together for the construction sector. So wherein we will be comparing what strategy which the market has now and how BIPV or PV integration into the architectural aspect of the whole market can change the market dynamics. As I had a discussion with my specialist group 2 days back, it was regarding the survey which we had. We have around 200 million square meters of glass facade already installed all over Dubai, and if we consider 40% of that 200, the 200 square million glass, putting that into PV would be contributing a lot of energy from renewables to the strategy which already they have. And Chris will be representing ASA event in Chicago, which is ASHRAE 2018, the Winter Conference, and these are the 3 major events lined up, and we have many more events coming up next week. Lots of talks are going on. Hope we expand more, and we anticipate to have more and more participation from different world. As of now, we have opened our representations in North America, South Africa, Middle East, and Asia. So we are trying to expand more, and hopefully we get more people on board. Thank you so much, Ronnie.
Thank you, Anup. And we're coming up to the hour here. I thank you for your patience. You've stayed with us. I think Chris will have some closing comments here, but I personally want to thank all of the speakers, Laurent, Anna, Anne, Chris, all the people who put their time into making this a success. I think if you can continue to reach out to us, you can send us emails or go to our website. But Chris, I'll let you close it up, and we probably won't have much time for any Q&A today, but you can certainly send questions into us via our website, and we'll shortly be sending out the email to you with a link to the recording and the presentation. So Chris, take it from here. Hello, Chris.
Sorry, Browning. Thank you so much. Yeah, and I just want to conclude by just saying thank you to everybody. If you'd like to get involved with the ASA, please do reach out. And if we'll go through the list of questions that we got, and we'll be able to answer them all via email. So we'll be sure to do that, and we'll send a mass email out with the answers to the questions, so we don't take up more of your time today. So thank you for your time, and we look forward to the next webinar.
And thank you, Araceli, ATA, Carlos, Belen, for your work in the background there. You do a lot of work, don't get a lot of credit for it, and all the speakers. Thank you again, and wish you a good weekend, and thank you. We'll close out now.